Welcome back, Mindsetters. I hope you had a nice little break. You did whatever you had to do, like I always tell you to do. You went and got water, or you got a snack. But make sure you guys do not go anywhere, and make sure you have your pens and pads and you're paying attention. That's the most important part. Pay attention to retain retention in the brain for mental stuffs. See, but that's why I keep quiet and hand over to Jacques, who's going to continue with the rest of the session. Take it away, Jacques.
Thanks a lot, Ty. Folks, let's look at our next example that I've got on the board. It says you must find the values of P and Q if, small p and small q, by the way, if point P, which is the point -3 and 2, is the midpoint of the line segment A and B. Now, always in analytical geometry, draw a diagram. Make a little sketch of what we've told you and put all this information off on the diagram. Transfer it. Let's see. There's the point A. A is the point P and Q, they tell me. Then they tell me that P is the midpoint. Now, that's the point -3 and 2. And the relationship there is it's the midpoint. And there's point B, which is the point -1 and 5. Now be careful again, there's a negative. When you have a negative coordinate, be wide awake because you are going to stumble over that double negative, folks. I've seen it happen so often. Okay, what did they tell me? They told me P is the midpoint of the line segment. So the relationship is, if I add the two extreme points and I halve the answer, I get the coordinates for P. Okay, remember your midpoint formula. Now they're asking me for small p and small q, so I can start off by saying the x-coordinate of point P is indeed the x-coordinate of A plus the x-coordinate of B, which is halved. Now the x-coordinate for P is -3. So I get -3, which is equal to the x-coordinate of A, and that's the P that I'm looking for, plus the x of point B. Now there's the negative coming in, so that is a -1. And that answer is halved. Now folks, that's the fraction. Don't like fractions in math, so let's get rid of it. Let's take the 2 and let's multiply it to the other side. Remember, I can do it because I'm working with an equation here. So the 2 comes to this side, I get -6, which is equal to P -1, and therefore P will be -5. Okay, so I've got the value of P. And remember, the condition was the midpoint is given. So the same thing is going to apply for the y values. The y of P is the y of A plus the y of B, which is halved. Now the y coordinate of point P is 2. 2 is therefore equal to Q plus 5 divided by the 2 at the bottom, and the procedure is exactly the same. Get rid of the fraction by multiplying both sides with 2. You get 4 is equal to Q plus 5. Gooi the 5 over, therefore Q is going to be -1. Folks, there's various ways that they can ask this question. They can give you 3 points, like they did here. They gave us P, A, and B. And now they can say to you that, you know what? The line AP is perpendicular to the line PB. Find the relationship between P and Q. Or they can put a P here and a 6 there and a Q there and a number there and do exactly the same thing. So be aware of what we spoke about earlier. When lines are parallel, their gradients are equal. When lines are perpendicular, their gradients multiply to a product of -1. And in this particular one, they've given me the midpoint. We've got another one that uses the distance formula. They say the following. The length of a line segment, now first of all they give me the line segment, there we go. The line segment is PQ. So if this is point P, remember it's not necessary to make it 100% accurate. As long as you always check. When is it necessary to have an accurate diagram? If lines are vertical or if they're horizontal, then it's necessary to check. Now they tell me something about that line. They say it has a distance or a length of root 13. Now they want me to find the value of A. Only thing you need to remember is I'm working with the distance of a line, so I need my distance formula. And what comes after that is quite interesting. So let us apply my distance formula. PQ is root 13. That they gave me. That's given from the word go. Okay? Now look at what I'm going to do next. I have got a square root on the one side of an equation. So to get rid of it, I can immediately, from the beginning, I can square both sides. Then I don't need to deal with this ugly square root. Okay, then the length of PQ. Let's see. What did we say? It's the difference in the y's that are squared. So if I look at that, it's a minus 4. A minus 4 all squared plus the distance between those x values. Be careful. 1 minus minus 2 is 1 plus 2 all squared. And that is the other side squared, which is 13. Now, folks, always at this point, get the variable to one side and get the numbers to the other side. This is a very easy equation to solve. You do not need to go and square that bracket. Look at what I mean. If I have a minus 4 on the one side, which is what I've got here, on the other side, here I have a plus 9. Why is it plus 9? Because it's 3 squared. So it's plus 9 equals 13. Now look at the poetry here. The 9 is going to jump over the equal sign. It's going to become 13 minus 9. So I will end up on both sides of this equation, I will have a squared number. And even if there wasn't a squared number, if that was 7, it's easier to say the root of 7 when I square root both sides. Okay, let's clean it up. Let's find the value of a. So what was an analytical problem turned into an algebra one. If I take the square root both sides, I get a minus 4. Now be careful. If I take the square root of 4, it can be plus or minus 2. Why? Because negative 2 gives me 4, and so does positive 2. And it's one step from the answer. A is equal to positive 4 plus or minus 2. Finally gives me A is 6, or the value of A is indeed 2. Okay, did we answer the question? Well, they asked us for the values of A, for which that line segment will have a length of 13. Okay, so it's not that bad, folks. As long as you know your formulas, you can do magic with your analytical geometry. Let's move to another example. My next example involves 3 points. I must choose one here, folks, because James tells me time's running out on me. So let me choose the one that works with gradients. They give me 3 points. They tell me point A is the point minus 2 and 4. Point B is indeed a point 2 and 7. And then point C is the point 4 and Y. Now they give me some extra information. They tell me that besides having the coordinates, I know that AB is perpendicular to AC. Now, folks, please, if you look at that, it should tell you a story. If you were to draw this diagram now, can you see that point A is shared? So the right angle is going to lie at point A, most probably. Not most probably, most definitely. AB perpendicular to AC. Do I need to know that? Do I need to draw it? I don't think in this case it's necessary. As long as you remember, because this was given, you can say that the gradient of the line segment AB multiplied by the gradient of the line segment AC has to be minus 1. If lines are perpendicular, the product of their gradients will be negative 1. If they go beyond that and they ask you, okay, where's the right angle? There's no need for you to go and work out all three the gradients and then decide. By that I mean find the gradient of AB and then BC and then AC and see what the relationship is. You can see which vertex has been shared. And that's most probably where your gradient is going to be perpendicular. Your right angle will lie there. Okay, let's see the gradient of AB. If I want the gradient of AB, be careful of negatives. So it's 7 minus 4 at the top over 2 minus minus 2. Remember I told you that double negative. So it's 2 plus 2. That multiplied by the gradient of AC. Now, if I look at the y values, I get y minus 4 at the top divided by that x value minus this x value. And there it is again, the double negative. 4 minus minus 2 gives you 4 plus 2. That product has to be minus 1. Now remember, these are two numbers. This is an irrational number, that's a rational number. I need to find the value of y. Okay, I get 7 minus 4, which is 3, and 3 over 2 plus 2 gives me 3 over 4. So here I'm stuck with 3 over 4 that I multiply with y minus 4 over 4 plus 2. That gives me 6, and that answer needs to be minus 1. Okay, now you guys can remember how to multiply fractions. I multiply a fraction by multiplying the numerators and dividing it by the product of the denominators. So at the top, I'll get 3 times y minus 4, and at the bottom you'll notice I'm not multiplying it in because I'm going to solve for y. At the bottom I get a beautiful 24, and that is still equal to minus 1. So now it's over to algebra again. Okay, if I multiply the 24 across, I get 3 times y minus 4, and notice I'm still not multiplying it in. That gives me minus 24, and now I can divide the 3 away. I get y minus 4, which is minus 8, and all that's left now is to kick the 4 over, and I get that y is indeed minus 4. All of this is algebra, folks. That's algebra. But you had to interpret the condition analytically. And the condition was there's 3 points given. The relationship was the 2 line segments that joins them are perpendicular. Use that to find the unknown value, which was y in this case. Okay, folks, I hope that helped you. And I hope that you realize you need to know your conditions and your formulas to do analytical geometry properly. Ty, up to you.
Yes, and on that note, on that awesome note, which all the mindsetters seem to be excited about, they said they just keep saying that they had fun, they've been enjoying the show, because a lot of them were saying that, you know what, it's like I get to go home and I can still continue my lessons from school.
Yeah.
So it's just like, well, that's what we're here for. So for me, I'm going to make sure that I peel through the page, so I make sure I find the mindsetter who deserves this the most. But from now, guys, I'm going to see you guys next time. So guys, make sure you tune in tomorrow even for the other lessons for grade 10s. So to make sure you do not disappear. But from us, we're going to see you next time.
Cheers.